Next 3 weeks, we're going to be looking at Java and looking at the crash course in Java, the basics. And I don't want to go over the history, but really quickly here, Java was created in 1995, I believe, as a language for a cable box set. Basically, they wanted a universal language that other companies could program in that language and make apps on cable box sets. It grew beyond that. The person that created it was James Gosling. He created it with, I think, 7 different principles in mind. One of them was that it looks familiar. So in other words, he adopted C-style syntax. He also wanted to make it simple. So we've got automatic garbage collection. We don't have a lot of the burdens that you had in, say, C or another language where you have to do your own manual memory management. At its basics, at its core, Java is a class-based, object-oriented programming language. Let me go ahead and increase the size on this just for those in the back. Oops, that's not what I wanted. There we go. Come on, focus, and then there. All right. What that means, if you want to get into programming language theory, great. But the translation of that is that everything in Java is either a class or belongs to a class. And I'm going to go ahead and mark that up because class is a key word in Java. That's how we actually created that Hello World class. Classes are simply units of code that are declared in their own source files. And maybe I shouldn't put simply there because there are a lot more, and we'll be getting into that a lot more as we get it deeper into object-oriented programming. But basically, as an example, if the class name is Hello World, oops, sorry, no spaces, world, there we go, then the source file must have the same base name, so hello world.java. Right? Now, if you're using an IDE, that is an integrated development environment over here like Eclipse, then all of that is pretty much opaque. You don't have to worry about that. When I showed this demo yesterday, when I created a new class, it generated a lot of this code for me already. But up here, public class, that's the class declaration. Hello world, that's the class name. And if I look over here, it's sort of difficult to see, but if you can squint, that's hello world.java. That's the source file over there. Okay. Again, IDEs like Eclipse sort of hide these details. And in fact, I didn't hit a compile. I didn't like say in C or C++ or something. If I were at the command line, I run GCC to compile this, right? The IDE is compiling that in the background all the time. So if I go in and make changes, or I screw it up somehow, right? Then after a moment or two, the IDE is going to compile that in the background and then report those syntax errors directly back to my text editor, right? And there. If you want to shut that off, you can do that. I'd recommend just keeping it on because it's always doing work in the background. It is always compiling in the background, and there are actually .class files. A .java file compiles to a Java bytecode, which is stored in a .class file. We won't look at that because, again, we're looking at an IDE from the perspective of an IDE here. All of that is opaque to us. It's all under the hood. We don't have to worry about it. Right? If you want to get into it, then you can start doing Java from the command line, just like you did, say, C from the command line. I think it's more important to focus on the actual language constructs rather than just the configuration. So that's what we're going to do. Classes are also organized in packages. Right? Packages are simply just directories. Right? That is folders, if you're familiar with folders instead of directories. Again, over here, when I created this unl.cse, I've got a package declaration up here. unl.cse, that means that if I were to actually go to the file system on this, I would see a folder called unl. Under that, I would see a subfolder called CSE. And under that, I would find the hello world.java file. Again, by using an IDE, it's kind of opaque to us, so we don't have to worry about that stuff. But you do have to worry about packages, because a package if you create a package declaration and you put it in a different package, for example, this is in unl.csc. If I go up here and change this package to unl.csc.foo, that's now a syntax error, because you said that it was going to be in this folder called unl, or foo, under this folder called csc, under this folder called unl, and it's not. It's under this folder unl.csc. So this is going to be a syntax error, and it's going to suggest a couple things here. Do you want to move it, or do you want to change the package declaration? And obviously I don't want to move it, because that's not a real directory, so I'll go ahead and change it back. You do have to be cognizant, though, of using the correct packages, because if the JVM, that's the Java virtual machine, if you tell it to run that hello world file, it's going to say, whoa, where is that located? You need to specify where it's located by specifying its package. Sometimes we call that a fully qualified path name or a fully qualified package name, unl.csc.hello world. Right? That's the full package name right there. Right? We won't be dealing with that directly. Again, by using an IDE here, that's kind of opaque to you. You don't have to worry about that. If you don't have a package declaration at all, that's perfectly fine. Right? It's not fine right now because this is not in the correct folder, but if I go down here and I move this up to the root of the source folder, right, and come over here, what's wrong? Oh, well, that's still wrong, but I didn't move it, I copied it accidentally. So now I've got two hello worlds. The second hello world is perfectly fine. There's no package declaration. Why? Well, because it's up here in the, you can't see this, but it's called the default package. So if you don't have a package declaration, then it's in the default package. If you have a package declaration, like, let me go ahead and undo that, like unl.csc, that means that it's in that folder, in that subfolder somewhere else. Okay? Let me go ahead and get rid of this. In general, sometimes we'll require you to put things in the default package just so that we can find them. Sometimes we'll specify other packages. In general, in practice, you do want to organize your code into different packages, into different folders, so that all that math stuff is in a math folder. All that stuff that that deals with customers is in that customer folder, or whatever, right? Whatever organization makes sense to you. Let me go ahead and delete this because I don't want to duplicate. Right? And there, we're back to normal. Right? So packages provide organization of your classes. Right? Just so that we have a copy of it, let me go ahead and copy over that that program that we've got here, and it's exactly what I had before. And now let's look at start looking at some of the key elements here. You'll notice that it has C-style syntax. Right? For example, executable statements end with a semicolon. Right? If you're coming from, say, a Python background or something like that, Python does not have semicolons. Instead, just going to the next line is how you indicate that you're going to the next line. Semicolons are like the period. Right? It's a punctuation. It tells the compiler, this is my statement, period, I'm done. Except it's not a period, it's a semicolon. Right? What else do you see here? Strings, or string literals, I should say. Literals use double quotes. What else? You have a main entry point that begins on executable program, bool program. If you don't have this, right? If you have, you can call. We'll get into function methods, but if you name this something else, my main. There we go. Now this is no longer an executable file. If I go up here to hit play, there's going to be a problem. Wait, there's no main method. It's not found in this hello world.java file. That means that this is just basically a library class now. You can use this class in other pieces of source code, but it's not executable. It's not something where you can start the program. And that's because I named it something else. Only when you've got this signature, public static void main or public static int main, do you have an executable program. Right? What other elements of C or C-style syntax do you see here? No? What? Blocks, exactly. So code blocks, code blocks are denoted with opening and closing curly brackets. Right? Again, that's another difference if you're coming from a Python background. Python background, your indentation tells you what, if you have a line and you're indented 5 spaces and the next line is indented 5 spaces, that's part of the same block. The bad part about that is if you have inconsistent indentation, 3 spaces and then 5 spaces, those are not part of the same block. But in C and in C-style syntax, we use opening and closing curly brackets, so none of that stuff matters. The beginning of the class starts right here with this opening curly bracket and ends with this curly bracket. Anything inside of that belongs to that class. Remember, in Java, everything is a class or belongs to a class. And we've got a method here that begins with an opening curly bracket and a closing curly bracket. Right? And I'm using the modern way of, I'm using a default Java style guide here, where the opening curly bracket is on the same line and the closing curly bracket is on its own line with the same indentation rate. Right? What if we, like you saw in your lab yesterday, what if we screw all of that up? Right? So, terrible, terrible styling on this. Right? No white space. It's all chunked together. It's all unreadable. In fact, I could even put it all on one line. Right? And I won't go that far. That's not a readable program. That's terrible style. How do we fix it? One keystroke. What was that? Shift, Command, F. That's Mac. Windows users, please help me out. Control, Shift, F to reformat it. All right? And sometimes people like to put in more vertical line space, and I like to do that too, just so that it's more readable. Right? Whatever styling convention you follow, fine. If you want to just go ahead and hit that one keystroke when you're done, great. But if you just get in the habit of writing good, clean code, right? If I go hit enter, it'll automatically go to the next line, the correct indentation level for me. Right? Any text editor, any code text editor worth its salt is going to do this for you anyway. Okay. All right. So we'll see some other parallels with C-style syntax later on, but those are the basics. Another key difference is that there is no memory management. Right? Java provides a garbage collector. And if you ever, this is a key difference between C and Java and a lot of other languages. C++, for example, you don't have, most C++ versions, you don't have memory management. You have to do it yourself. If you create an array of 1,000 integers, right, then you can use it as much as you want in C. If you create that, but once you're done using it, you have to free it up. Otherwise, that memory is being held by your program and is not available to your program or other programs. So good memory management means that once you're done using it, you free it up. In Java, you don't have to worry about that. If you have an array of 100 integers, you start using it, you use it, you no longer need it. Once it goes out of scope, that is, say, once you return from a method or something like that, Java sees, oh, okay, nobody's using this anymore. I'm going to mark that down for garbage collection. And then when Java thinks it's best to do garbage collection, it goes in and does garbage collection. There are very sophisticated algorithms that, to do this. Don't worry about, in fact, you can't force garbage collection to run yourself usually. There is a system.gc to run garbage collection. It's actually just a suggestion. Please, Java, if you think it's okay, go ahead and run garbage collection right now. And then it's, no, I don't want to do it right now because running garbage collection is rather expensive. Going through everything that no longer has a reference to it and saying, okay, I'll free that up, that takes a lot of time, with a lot in the scope of a computation of a computer. And it says, well, by doing this, I would only free up like 50 bytes. There's no reason to do this right now. It says, no, I'm not going to do that. I'm not going to waste time when the payoff is not that big. So there are very sophisticated algorithms that do this for you. No garbage collection whatsoever. Right? Very nice. Until it is no longer nice. Right? It's portable. Right? You write a Java program once. You compile once. Then you can run it on any machine machine with a JVM. So what is JVM? That's a Java virtual machine. So again, it is compiled, but you're compiling it to Java bytecode. This is a special machine-style language that is not run on a processor. Instead, it's run on a virtual machine that sits on top of your operating system. With C, you compile it directly to machine code that runs on the processor. Above that, you have the operating system, and above that, you have programs. One of those programs can be the Java virtual machine. It's basically a simulation on top of real hardware. So in Java, you compile your bytecode to be run on this machine rather than the actual processor down here. That's why you can write it once, compile it once, and then run it on any machine, a Mac, Windows, Linux, whatever. You can run it on any machine that has a Java virtual machine built for it. Right? The default Java virtual machine is, of course, put out by Sun. Oh, sorry, Sun. Sun was bought out by, Java was bought from Sun by Oracle. Oracle owns it now. But there are plenty of free alternatives. In fact, the Java version, the Java JVM and the JDK that are installed on the CSE servers are OpenJDK. It's not owned by Oracle. So even though Oracle might control it in some regards, they don't control everything, and there are plenty of free alternatives out there. Right? Comments are also C style. You have, for example, let me go ahead and just pull this over here since we've seen it before. You have single line comments and multi-line comments. Single line comments start with a // right? Because you are leaning forward when you face that way. And everything after that is ignored all the way to the end of the line. Multi-line comments begin with a /* and end with a */. Anything between there is going to be ignored. You might also see me using what are called Javadoc style comments. There's nothing fancy about these. It's just multi-line comments, right? It begins with a /* and ends with a //. But note the rest of the formatting here. We've got double star on the top. And then we've got these vertical stars that align stuff up. It's basically kind of like ASCII art. Let me go ahead and go over here and show it to you in Eclipse. If I start this with a that's a /**, and I hit Enter, it starts generating some comments for me. For example, the author, me, right? It put the author down here. You can start writing some Javadoc style comments now. I'm going to tell you the purpose of this program. This is a typical Hello World style program. Okay, let's go ahead and go with a date. I don't know. Oh, nope, that's not supported. So what is today? 2019, 01, 10. There we go. Right. For more information on Java, see href equals Java. I need an actual website here, so Java documents. All right, there we go. There we go, and Java documentation. There we go. What did I just put into my comments? What is this thing right here? That's HTML. It's a direct link. Why would you want to do something like this? Well, let me go ahead and hover over this. And unfortunately, it's rather small, but you can see what it renders it as HTML in my own IDE. If I go over here and click this, oh, hey, it takes me to that website right in my IDE. Right? You can have a very, very powerful style of comments. In fact, you can link to other things. Let me go ahead and link to the main. Nope. What is it going to be? Main. Yep, there we go. There. Well, what does that look like now? There's now a link here. You can't see it very well. Let me go ahead and put it in. The only method in this class is the main method. There we go. And now let me go ahead and hover on this. There. If I click that, it'll take me to the actual documentation for that main method. I don't have any documentation right now, so let me go ahead and put it there. This is the main method. Right? So let me go ahead and go back over here see that I can link to that method, and it'll take me to the documentation for that method. You can't see it, but it says this is the main method, right? So you can make linkable documentation using Javadoc style comments. Not only can you do this in the IDE, but if you're doing a real project, a real large project, and you've documented it along the way, you can hit a button, a program will go through all your Javadoc style comments, pull them all out, generate a web page, and now you've generated all the documentation for your library or your program or whatever, right? This is one of the benefits of embedding stuff in a doc style way of in your actual program. I believe it originated with Java. That's why we call them Javadoc style comments. But virtually every language has adopted something like this. There are CPP docs, PHP docs. Basically, they adopted this style of syntax of the star along with vertical stars all the way down, so that you can denote that this is a doc style comment that should be parsable, and it contains a bunch of links and stuff. And you have a program that goes out and takes care of everything for you, right? We will not require doc style comments, but you should probably get into the habit of writing them, right? Now, this is way overkill for a Hello World program, right? This is way too much documentation. The documentation outstrips the lines of code by a factor of 10 to 1. That's way too much. But we do expect a minimum of documentation on all of your programs, okay? All right, so those are the doc style comments. Adopt them now, or you're going to have to adopt them later. All right, let's talk about variables. Variables, right? So Java is statically typed, right? Meaning that you have to declare a variable's type and name before you use it, right? This is just like C, C++, any statically typed language. If you're coming from a Python background, Python is dynamically typed. Meaning that if you want to, if you create a variable here, a, you don't have to declare it. You just say a is equal to 10. And you've got a variable that it represents an integer. Later on in your program, a doesn't have to always be an integer, right? It could be a string. So you say a is equal to ten with double quotes, making it into a string. That's dynamic typing. It might seem cool at first, but believe me, it gets you into trouble really quickly. The second that you even have a function, now your function has an input, a. What type is a? An integer? A string? Well, I wrote this function under the assumption that it's a string because I'm doing string processing. That stops nobody from calling my function and passing in an integer, passing in a double, passing in an object, right? Now all compile time errors become runtime errors. So statically typed languages are actually a very, very good thing. And I think that they are winning the war. There are plenty of examples that I can point to. For example, PHP and JavaScript, they're dynamically typed, but they have languages built on top of them that provide static typing. JavaScript, for example, CoffeeScript and TypeScript are statically typed languages that are built on top of JavaScript to provide that static typing so that you don't have that problem of, here's a function and it takes a variable. Anybody can pass anything that they want to it, right? And so static typing is a very, very good thing, right? And it means that it means that you do have to decide what your variables types are before you declare them. Java, let me go into code mode here. Int a is equal to 10, right? This is an integer variable. Come on, integer variable. You also have doubles, 3.14 for pi. You have chars, equals C, right? Oops, semicolon there. You also have, in Java, short, long. So there are 9 primitive types, I believe. So I've got 3, 4, 5. You also have Boolean, right? Flag equals true, right? Let me go ahead and go down there. So 1, 2, 3, 4, 5, 6. I'm missing. I've also got byte. 7. There are 2 more. Float. Thank you. And the last one is short, long. I've got char, right? 1, 2, 3, 4, 5, 6, 7, 8. I'm missing one, and I can't think of it off the top of my head. Oh, there are only 8? Java primitive types. Oh, there are 8. Okay, I was off. I got them all. Yay! All right, that's kind of a stupid interview question. Java has 8 primitive types. What are they all? Right, and then you go through the list here. I put these into comments because we're not going to use them too much. Why not float? Float is just a less accurate double. If you're doing something where you don't need the accuracy but you need performance, say like game development, then yeah, go ahead and switch over to float. Because it doesn't matter if you have 16 decimals of precision when 2 balls are colliding, right? That would be a float is good enough where you've got 8 digits of precision. That accuracy is down to 1 pixel, right? And it's faster. Short is, I believe, only a 16-bit integer value. A long is going to be a 64-bit integer value, and a byte is only an 8-bit, and it's not really a number. You can treat it as a number, but it's only going to be 8 bytes. A double is going to be a 64-bit IEEE blah 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 floating point number, so it has about 16 decimals of accuracy. A character is going to be it's actually not an ASCII text character. You can treat it like an ASCII text character, but it's a full Unicode character. So you could, theoretically, do things like this. I'm going to have to go back to a happy face emoji. There we go. And I'm going to have to cut and paste. There we go. So you can do, but you should not do things like this. There we go. Oh, it usually does. It's my configuration. That's why. So I'll go ahead and go char. X is equal to, hopefully I can do this at least. Nope. Say what? They're UTF-8 characters. And so I'd have to escape this. Where's the escape character here? Smiling Unicode character escape sequence. There we go. It's this. Come on, where is it? There we go. I have to do it like this. It should work with a single character like this, right? Yep, there we go. And now let's go ahead and append X to it and see if it actually prints this out. It should, because it was supporting it before. Okay. It is a smiley face. It's just not the full, colorful one. It has a different character set down here than it does up here. I believe you can in full Java. It's not letting me do it because I've got a sensible setup up here. But you can use UTF-8 characters as I believe. I might be wrong on this. I believe that you can use them as variable names. Don't use them as variable names, though. All right. Let's get rid of that and get rid of that. Don't worry about it, though. For all intents and purposes, a char is going to be an ASCII text character. If you ever need an actual char, I would encourage you not to use chars, because one of the advantages of using Java is that you have full strings. So Java has a built-in string class. The built-in, if you're coming from a C background, you remember how terrible it is to work with strings in C. They are a character array that has to be null terminated. And you can't just go ahead and take this and concatenate it to this. You have to create memory that's large enough to hold those things, copy this over, then copy that or concatenate this over. So it's a lot of manual work. But in Java, you have a string class. You can declare a string and assign it without worrying about any memory, because again, you don't have memory management. So Java, let me go ahead and create a string here. String name is equal to Chris. In fact, let me go ahead and rename this. First name and my last name, right, is equal to Burke. And now if I want my full name is equal to, I'll go with last name plus, I'll mix in another string there. All strings are going to be denoted with the double quotes. Comma, space, plus first name. There we go. And now what are the contents of full name? It's Burke, comma, Chris. And if I printed it out, that's exactly what I would get. Okay? However, strings are in Java are immutable. Immutable means that once created, they cannot be changed. Right? This is not like C. When C, if you create an array, you can go ahead and change it. You can do whatever you want to it, right? But in Java, you can't do that. Once it's created, it stays that way. Immutability is a very, very good thing, right? Immutability gives you thread safety. If you have a piece of data that you have a guarantee that nobody can change it once it's created, that means that you can have multiple threads, 10 different threads in a computer, try to access it. Well, you know that thread A can't go in and change it and pull the rug out from thread B. Right? And that's a very, very good thing to have because it gives you automatic thread safety. And so once it's created, if you need to create a new string with different content, guess what? Just create a new string. Right? Let me go ahead and make a string full name is equal to Chris Topher. Right? There. I've reassigned, oh, sorry, I shouldn't have string there. I can reassign a string. So the old string, I'm not changing the old string. I've got two strings here, Burke, comma, Chris, and then I'm creating a new string, Christopher, and I'm simply making full name refer to that new string. That old string is still there. I didn't change it, right? And now, but I don't have access to it anymore, so the Java virtual machine takes care of it for me. You need to go in and clean this memory up that contains Burke, comma, Chris. The Java virtual machine will take care of that for you, right? So let's take a look at an example over here in an actual piece of code. Let's go ahead and create a string s is equal to hello. Hello. And I didn't capitalize it, right? So string, I'm going to preserve that other string s, but I'm also going to make t now. I'm going to make s equal to hello with a capital H instead. Right? I actually have two strings here. I have a string that contains lowercase hello and a string that contains uppercase hello. And if I print those out, let's go ahead and go with s and t. Right? What order are they going to be printed out in? Which one is going to be printed first? The uppercase or the lowercase? The uppercase, because that is what s is referring to here. T is referring to the old s, which is lowercase hello. So when I print out t on line 28 here, it's going to print out lowercase h. Right? There. How can I convert to all uppercase? Let's say that I want to go with t dot to uppercase. There we go. Does that convert the string t? Let's find out. All right, that is a function that's part of the string library. To uppercase, well, it should take that hello and convert it to capital H, capital E, capital L, and capital O, right? Does it? Let's find out. No, it stayed the same. Why? Because it's immutable. You cannot change it. So what is the point of having a to uppercase method there? It returns a new string. stu. There we go. There. Now let's go ahead and, well, let me go ahead and get rid of this stuff. Oh, there's a trick. What did I just do? I commented out multiple lines. How do I do that again? On a Mac, it's going to be command /. You can comment, uncomment entire blocks of code. On a Windows machine, it's going to be control / I believe. Okay. And because I just want to focus on these two right here. T will be retained as all lowercase because that's what it cannot be changed. But U, the to uppercase, that's returning a brand new string that I'm capturing in the variable U here. And so it's also going to be all uppercase when I print it out. Right? Remember, strings are immutable. If you want a new string, create a new string. You cannot change that old string. Okay? You also have demo. Let me go ahead and cut and paste this so that I'll go ahead and undo that. Just so that you have this code. Java. There we go. When I eventually post these notes, you'll be able to run have that code and run it if you want. All right. Java also has full a full Boolean type. All right. Most languages do, and in fact, C has an extension that allows you to have true and the keywords true and false. But if you're coming from a pure C background, we didn't have a Boolean type. Remember, 0 was interpreted as false, and anything else was interpreted as true. 1 was true, 10 was true, 5 was true, 2.5 was true, right? The null terminating character was false, but A, B, C, D, all of those things were true, right? But Java is different. Java has a full Boolean type. Boolean, that can be assigned the values true or false. Right? And you would use these Boolean values in expressions. If you want to create a flag variable that holds true or false, you can do that. And we'll talk about this when we get to conditionals, but all conditionals have to be a true or false value. You can no longer use, say, plus or numbers as placeholders for true and false in Java. Right? It is truly a much better situation than you might have seen before. Okay. Java also limits typecasting, implicit typecasting. Right? So just so that those unfamiliar with statically typed languages, tell me what happens in the following. Int A is equal to 10, int B is equal to 20, int C is equal to, let me go down here, A divided by B. What is in C? Right. So those coming from a C background, what's in C right? What's in the variable C right now? If that's C, if that were C code, 0. Why? 10 divided by 20, that's 0.5, right? But it's an integer divided by an integer, so the result has to be an integer. So 0.5, that's not an integer. What happens is we take that fractional part, cut it off, and throw it away. What am I left with? 0. Right? That's called truncation. Let me see what happens when I try this in Java. Let me go out and go back over to my IDE here and get rid of all this stuff and put this here. Right? So system.out.println C. There we go. 0. Same thing. Actually, I was kind of expecting something else, but oh yeah. Now let me try something else. I want it to be a double. What happens now? Let's find out. 0.0. Right? Why? Because the expression was done on the right-hand side. A divided by B, that's still integer divided by integer, so the result is going to be an integer. It doesn't matter if you put it into a double. Right? But what happens if I do try to do something like this? Double D is equal to 10.5. There we go. Oh, it's letting me do this. What? Okay. Let's print this out. D. There we go. 10.5. Okay. This seems kind of fishy to me, and maybe it's because it's now it's an updated Java, but I'm not sure. Anyway, this will actually work now. But if I try to go with here, this is what I wanted. There we go. Finally, I finally got what I wanted. What did I get? A syntax error. What's wrong? Int D, that's an integer. What's the thing on the right-hand side, though? That's a floating point number. That's a fractional number, 10.5. It's not letting me do that, right? Why? Let's ask Java why. Let's go ahead and hover over this. Type mismatch. Cannot convert from int to double, double to int, excuse me. That's called downcasting. When you go from a more general type, 10.5, to a more specific type and lose precision, that's called downcasting. And in C, you could do this. The result would be D would have 10. It's not rounding, it's truncation. You take the fractional part and you throw it away. But in Java, Java does not allow you to do this. Right? Java says, wait a second, that's implicit typecasting. You don't want. Are you sure that you want to do this or not? right? And if you're absolutely sure that you want to do something like this, then Java will allow you to do it through an explicit typecast. Well, sorry, not double, int, right? And then it's perfectly fine with it. Right? It was already a double. I typecasted it to a double. That doesn't make any sense. So I take it, it's a double. I typecast it to an integer, and now it's perfectly fine putting that into an integer. Java is OK with you doing this as long as you're explicit about it. If you are implicit about it and say, I want you to automatically take care of this like you do in C, Java compiler is going to say, no, I'm not going to take care of that for you. Make sure that you are doing something intentionally, right? And so you can do it like this. Okay. Also, another observation that you cannot assign true or false values to an integer because an integer is not a Boolean. If you want something like this, you have to create a Boolean variable. Only Booleans can accept the values true and false. Right? Boolean. Oops. And it's all lowercase. It is case sensitive. There's no such thing as uppercase true. There's no such thing as capital T true. Everything is lowercase here, and you can see that by the syntax highlighting. Okay. All right. Let's see. Did that? Operators. Oops. I don't want to get rid of that. There we go. Operators. Operators. There we go. So there's basic arithmetic. You have plus, minus, minus, multiplication, and division. And all of those act as expected, right? You also have integer division, right? You've got the percent sign. Oops, there we go. What happens with, let me go ahead and go over here. Let me go ahead and get rid of this stuff. Int C is equal to A, integer division by B, right? And let me go ahead and print that out. What's the result going to be there? What happens when you take 10 divided by 20? What's the remainder of that? Does 10 go into 20 even once? Nope. So what's the remainder? Let's find out. It should be 10. Right? What happens when you divide, say, 8 by 2? What's the remainder there? It's what? 8 divided by 2, and then you have a remainder. 8 divided by 2 is 4. Is there any remainder there? No, so it's going to be 0. Right? 8 divided by 3. 3 doesn't go into 8 wholly, right? So it goes into it twice, and what's the remainder there? 2. So oops, yes, save it and compile. And there 2. 8 divided by 5. What's the remainder there? 3, right? So integer division, this thing right here gives you the remainder after the division, right? So it produces the remainder of the division. Right? So for example, if I go 8 mod, and the way that you read this is mod, 8 mod 3 would result in, what was it again? 2. There we go. You also have logical operators. Right? You have not, you have the logical and, 2 ampersands, and the logical or. Right? So this is, let me go ahead and label these for those coming, say, from a Python background. Python, you don't use these. Well, I think you might be able to use them. I'm not sure. But Python, you use what instead? The words and or, right? Oh, you can use them? Okay. Oh, okay. Okay. That's not a bitwise. That's bitwise in Python. Okay, I have no idea. In any case, don't use those because those are bitwise operators in Java and in C and in most programming languages, which will not give you the results that you want. You want a true and false. That's going to be false. True and true. That's going to be true. But if you do that with bitwise operators, then it starts depending on the bit sequences themselves, and now it could be false or true depending on what bits you have. So you always use the ampersand, and we sometimes call these pipes or Sheffer strokes. So pipe, and then the exclamation point is not, right? And you also have inequality operators. You have less than, you have less than or equal to, greater than or equal to, and equals, right? And not equals, right? So you have all of those if you were wanting to compare numbers. Strings. How do you compare strings? You cannot compare strings using the numerical comparison operators. Right? Let me go ahead and show you an example here. Right? Let me go ahead and create a couple of strings. String s is equal to hello. Right? String t is equal to world. If s is equal to t, then I'll go ahead and print, how do I print stuff? System.out.println. The strings are equal. Well, of course, is that true or false? Is hello equal to world? Nope. Else, I go ahead and say that they are not equal. Right? Let's run this. You would expect it to say that they are not equal, right? And they do. But what if I change it so that I've got hello and hello? They are equal in the sense that they contain the same string, right? What's it going to still say, though? Oh, darn it. Let me go ahead and go with new string. That's the Java virtual machine optimizing stuff away for me. Let me go ahead and do it that way. There we go. They're not equal. What happened in that first version was a Java virtual machine compiling my code and seeing, wait, you have two exact strings. I'm not going to create two strings. I'm going to create one and make s and t point to that same thing. By explicitly saying a new string here, I'm saying, no, do not optimize that. I know what I'm doing. Please go ahead and create two distinct strings with the same content. And so when I go ahead and try to compare them using equals, it's going to say that they're not equal, even though they both contain HELLO with the same casing and everything. Why? This is a numerical operator. It's going to let me do this, right? You're not seeing any compiler errors here. It's going to let me do this because this is valid Java, but it's not comparing the contents of the string. It's comparing their memory addresses. Right? Let's go ahead and print out. There is a nice way that you can print out the memory. Nope. Sorry, there's no easy way to print out the memory address of a string in Java without me doing some work. But these memory addresses are completely different because I said this one's a new string and then that one's a new string. So they're two distinct things in memory. They each have different memory addresses. So when I go and compare these memory addresses, which are numbers, it's saying, well, no, that's not the same memory. So it's, obviously they're not equal. And that's why I'm getting a report that they're not equal, because they're not the same memory address. Now, how do I do this? How do I actually compare strings to each other? I would need to use something else. If s dot compare to, let me go ahead and do one way of doing it, equals t, then I will print out that the strings are equal. Right? And is s equal to t? Yes, they are equal because the contents of the strings are equal. They both contain HELLO in the same casing. Another way of doing it is to use another. That only tells you that they're equal or that they're not equal. It doesn't tell me something more important. Does this come before this, or is it the other way around, or are they equal? Right? It only tells me that they're equal or that they're not equal. That it doesn't tell me that one comes before the other. In order to get that kind of functionality, you can use compare to. Right? Now, compare to is not going to return a Boolean true or false. It actually returns an integer. And that integer is going to be equal to 0 if they are equal. Else, if compare, let me go ahead and grab this. If it's less than 0, then I'll put in that s comes before t. There we go. Plus t. There we go. All right. Quit correcting stuff for me, please. I'm fighting the IDE right now. There. That looks good. Else, if the only other possibility is what? If that is going to be positive, right? So let me go ahead and put that in. If it's greater than 0, right, it returns a positive number, then t comes before, or let me preserve it comes after. There we go. And let's add some more in there. All right. And let me go ahead and get rid of this. I'll preserve it for the notes. But now what's going to happen here? Compare to hello and hello. They are the same. They have the same contents. So they are, they're conceptually they're equal. So I should expect it to return 0, that the strings are equal. Let's run it and see. Yes. Oh, sorry. Where am I? At the end, you're missing a bracket. Thank you. There. All right. They are equal. Right? What if I have instead? What if I have apple and banana? There we go. What order do those come in? Which one comes first, apple or banana? Apple. Why? You're thinking alphabetically, right? So let's go ahead and try this. Apple comes before banana. If I compare apple to banana, that compare to function is going to return something negative. Now, if I switch them around, banana and apple, then it's going to return something positive, that they're out of order, and so it's going to say that banana comes after apple, right? What if I compare apples to apples? Well, apple to apples. Which one of those comes first? First of all, they're not equal, right? One of them is singular, one of them is plural. So which one comes first? Apple, right? Apple comes before apples. Why? Because of the ASCII text table, just like C. If you're coming from a C background, you have a string comparison function, right? strcmp. In Python, I think you can use the numerical operators and it'll do it for you, but that's because, again, it's dynamically typed. What happens if I change it to, let's go like this. Lowercase a apple, uppercase a apple. Which one of those comes first? Uppercase. Why? Because of the ASCII text table, right? Let's go to the web here, ASCIItable.com. Right? There's the ASCII table. Where does capital A come in? 65. 65 comes before lowercase a, which is 97. That's how the ASCII text table was set up. And for that reason, lowercase a apple comes before uppercase a apple. Right? What about if I make this one plural then? Right? Same thing. Because it finds the first difference at that first character. Okay? What about 120 versus 5? So which one of those comes first? 120. Oh, okay, got an answer of 120. Anybody else? All right, that's the correct one. Why is it not 5? 5 comes before 120. If I'm counting, 5 comes before 120, right? 5 comes after 120. Why? It's not treating these as numbers. These are ASCII text values. And if I go over here to the ASCII text table and I see the numbers here, 5 comes before that 1. Right? Even though that you've got other digits after it, it's treating it as not as a number, but as a string. Right? So 5 comes after 120. Right? Now, if I had 500, now what happens? 500 comes after 120. Now it makes sense, right? But that's immaterial. It found that difference in the first character. In other words, the takeaway from this is that it's not alphabetical order. In fact, let's go ahead and go with one more example here. Apple, or say banana, and lowercase a apple. Right? If you were in a dictionary, right? You open up your dictionary and you look up the definition of banana or apple. Which one comes first? Apple. But in this case, which one comes first? Banana comes before apple. Why? Because an uppercase B trumps that lowercase a because of the ASCII text table. It is not alphabetic. It is not like a dictionary. It is according to this ASCII text table right here. Right? So keep that in mind. If you want alphabetic, then you're going to be writing your own comparators, and we'll get to comparators later on. Right? All right. So I'll go ahead and cut and paste it. Oh, go ahead. Question?
No, I just wanted to, or you just add either to uppercase or to lowercase.
You could do that, or one other thing I should have showed you is, what if you don't care about uppercase, lowercase? Compare to ignore case. There we go. And now let me go ahead and go with one more example here. Apple, or let's go with elite speak here. There we go. And now they are equal, even though they're not equal, right? But that's because I'm calling the compare to ignore case, right? Now, if you had other non-A through Z characters in there, then there's no such thing as an uppercase exclamation point. That would make a difference, right? All right. Basic output. Output. We'll start with basic output. So as we've already seen, Java supports the standard output using system.in. Or sorry, in. Output, it should be system.out, right? Where you can use say system.out.print, right? You can use system.out.println, right? And this one adds an end line character for you. The first one doesn't, of course. It just prints it whatever you want. You can also use printf. So system.in.printf will get you a printf style formatting, right? And just to show you as a review, here are some examples. If I've got 3.14159.265, what's it going to print? I shouldn't have put the answers in there right away. But by default, it's always going to print out 6 decimal places of accuracy, right? In this case, however, it prints out 3.14159.3. Why? It's rounding it for you, right? That does not change what's stored in that variable pi. It only rounded it up for the purposes of printing it out. If you only want to print out to 2 decimal places, then you provide period 2 to specify 2 decimal places. And in this case, it's still rounding, but it's 141, so it rounds down. And it gives you 2 decimal places. If you want it out to 50 decimal places, right, then you can do something like this. What'll it print? Maybe that's why I didn't put the answer there. What'll it print? Good question. I don't have pi here. It'll probably just print zeros, right? I think we might have done this on Tuesday. Yeah, it's all just zeros. If you were to do this in, say, C or something, and you tried to print it, none of these are accurate, by the way, right? A 64-bit floating point number is only accurate out to about 16 decimal places of accuracy, or 16 digits of accuracy. So all those zeros, that's Java thinking, okay, well, there's nothing out there, so I'm just going to put zeros. In a programming language like C, well, you might end up getting garbage in the lower order bits because then it has to guess as to what to print. But with Java, it's printing all zeros. What if I added this? Bunch of ones. There we go. Let's find out what happens here. Obviously, that's way more than 16 decimal places of accuracy. And what happened to that 1 at the end? Do you see it here? Nope, because it was lost. You can only represent it out to 16 decimal places or digits of accuracy. So that 1 way out there got truncated off, got thrown out. Okay. That's an inherent limitation of any finite precision representation of numbers. As an aside here, if you do really want multi-precision, you can build, I think Python 2.7 and above, or maybe it's just 3, I forget. Some versions of Python support multi-precision. In other words, if you want pi out to 1,000 decimal places, it'll do it for you natively. In Java, you have to do something different. You have to use, say, big decimal, right? Big pi is equal to new big decimal, right? And then what you have to do is you have to convert it as a string, I believe. Maybe this is how you do it. Otherwise, it's going to be, what is it, big? I have to import. Oh, here's a good opportunity. It doesn't know what this thing is. Big decimal, what's that? That's because it's in a different library. It's in the java.math library. So you can hover on it, import that, and that'll be now re-resolved. Up here, import java.math.bigdecimal. That's very similar to what you use, say, in C, where you include an external library, include math.h. Even in Python, you have to do something like this. In Python, what do? I think it's still import, right? Import, and then you import an entire package using a string representation of it instead. And so, yep, this works. And now let's go ahead and print out big pi. Right. here, I'll just print it out like this. Big pi. There we go. Print ln. There we go. Big pi. Oh, I should have gone to the next line, darn it. Next line. And now big pi. Ooh, hey, look at that. That 1 is preserved. In fact, just as a fun little thing here, 1,000 digits of pi. Not pi. 1,000 places of pi. There we go. Oh, come on, really? It's probably going to complain about this multi-line thing here. Oh, no, there. Neat. So what did my IDE do for me? It concatenated them all. But, darn it, it put in a bunch of n-line characters, right? Let me go ahead, and I forgot the 3 too. I think I forgot the 3. Let me go ahead and align them all up. Put a bunch of n-line characters. That's not going to work, right? And then, what's it complaining about here? Oh, this. And then, there we go. Now it's probably going to print out yeah, it's going to be a problem here because there are a bunch of n-line characters in here from my printing statements. This is what I showed you on Tuesday. How do I get rid of all those? Okay, well, delete. I don't want to do all that work. Let's go into block code, or block selection mode. Get rid of all of them at once. Right? And again, on Mac, that's going to be Option Command A. On Windows, Alt Control A, I think. I'm not sure. Now let's go ahead and see if it works. Uh-oh. Exception, number format exception. It's not liking all the spaces either. Sorry. Let's get rid of all the spaces then. There we go. There. Oh, darn it. Undo. There we go. Now all the spaces are gone, and now it's perfectly happy. There are 1,000 digits of pi. And it's all represented because I used this other class, big decimal. Now, you're paying a price for this. It's not going to run, things are 32 bits and 64 bits for a reason. Because when they run on the processor, processors are built for that. They are built for processing 64-bit numbers. They're not built for processing however many bits this takes. Instead, it all has to be done in software. So if you need more memory to hold more bits, it'll allocate more memory for you. But that process is at a higher level. It's in the software level rather than the hardware level, meaning that it's going to be a hell of a lot slower than if you had run it on the actual machine, or the actual metal at the bottom, right? So you can do this if you need to, okay? And I'll go ahead and save that. So you can, well, what about integers? You can use big decimal. What if you just want an integer though? Or big integer for or arbitrary precision arithmetic, if you really need to. Okay. All right. Good. Fast forward all this stuff. We don't need this. So conditionals. All right. Java supports basic, if, else if, or if, else if, and I should have gone if, else statements. All right. It also supports switch statements with both integers and strings. Although I won't be covering those too much because I don't like switch statements. Unless you're doing something like a finite state machine or something, switch statements are problematic because you have to have, because of fall through, you have to have break statements. They're very limited in that, in fact, in Java 7 and prior, you could only do it with integers instead of strings. And so even now, you can only do it with integers and strings. You can't do any ranges. You can't do doubles. If a number falls between 0 and 10, or it falls between 10 and 20, or it falls between 20 and 30, you can't really do that easily with a switch statement. So I tend to stick to exclusively if-else-if statements. And of course, you can do nested ones too. We already did this as an example up here. I've got an if, else if, else if. The else is always optional. System.out.println, something went really wrong. All right? Why would I say something went really wrong? Well, I've got three mutually exclusive conditions here, right? It's either equal to 0, it's negative, or it's positive. There's no fourth option there. So this is, in essence, dead code. All right? This should never happen. Now, on the off chance that you're designing your own program, I still like to always have an else statement and with a message like this that says something really went wrong. If I'm processing a file and I have an assumption that every line begins with either an A, a B, or a C, then I can have three conditions there. It begins with an A, or else if it begins with a C, a B, else if it begins with a C. I like to put that else statement in there because if the file is screwed up, I want to know, right? I don't want just to do nothing, right? So an else statement is usually a good idea to put at the end. Usually you would throw an exception here. We'll get to exceptions later on, right? But for now, something went really wrong. This should never happen, right? I want to know about that, and I want to deal with that. Okay? Let's see. Conditionals, switch statements, and in Java, let's go back over here. In Java, all logical expressions must be true or false. Right? And I'll go ahead and syntax highlight those as true or false. In other words, you can't do something, if you're from a C background, you can't do something like this, int x is equal to 10. Normally that would be true in C. And in a lot of other programming languages, it would be true because it's non-zero. And you can use that as a flag variable. System.out.println, foo, right? You can't do that. You can't, it's an integer. We're in Java now. You have a Boolean type, you have to use it. You can no longer use that jury-rigged numerical type for true and false values. You have a Boolean type, now you have to use it. And you can't assign it to numbers. You have to assign it to true or false. Right? So that's another takeaway on conditionals. Otherwise, loops. Any questions about conditionals? Because again, everything that you've learned about conditionals in most other programming languages applies to Java. Why? Because almost every programming language is C-style syntax. You've got the same keywords in most programming languages. And the same is true of loops. You've got for loops. For loops. Right? I'll go into code mode here, and we'll just do it right here instead of going over to the Eclipse. For int I equals 0, I is less than 10, I plus plus. Oops, plus plus. Right, there we go. System.out.println I. Whatever you're going to do with it. All right, that's a basic for loop. I've created an index variable here, I, a counter variable or whatever. While I is strictly less than 10, do whatever is in the loop body here, and I plus plus. Okay. Now, if you're coming from a Python background, this is definitely not idiomatic Python. You can do something like this in Python, but usually you would do something like for x in range 0 to 9. But it's different. We don't have that in Java. We have a regular old for loop here. With an initialization statement, you start I at 0. A continuation condition, while I is still less than 10, strictly less than 10, you update the variable I plus plus, you add 1 to it each time. So what is this ultimately going to print out? 0, 1, 2. What's the last thing that it prints out? 9. Why? Because when it goes up to 10, 10 is no longer strictly equal to, less than 10, and so it jumps out of the for loop. Right? You also have while loops. While loops. Right? Oops. Java. Right? While I is less than 10. Oops. And I need that variable int I is equal to 0. Add some more white space here. And this, I'm just going to cut and paste this. There we go. All right, what does that one do? Yeah, let's find out. Let's run it. All right, Okay, perfectly happy with my syntax. Run it. It's going on forever. Why? It's not incrementing I. I is always 0. It's always less than 10, so it prints 0, prints 0, prints 0. I wanted to do this, though. How do I stop it? If you were at the command line with C, you would go Control-C to kill the current working program. If you were in some other IDE, you might see something very, very similar. How do I stop this? Well, how did I start it? I hit the play button, right? How do I stop it? I hit the stop button, which is a little red square down here. Stop it. Right? You can clear out the console by hitting those X's as well. So if you ever get into an infinite loop, just go ahead and stop it. You can, by the way, because it's an IDE, you might get yourself into some trouble like, okay, I double-clicked it instead. I triple-clicked it instead. I quadruple-clicked it instead. I've actually got 4 programs running right now. Right? I will stop one. Okay, well, there's that third one. Stop that one. Stop that one. Stop that one. Stop. Oh, how many times did I hit it? There we go. Now they're finally all stopped, and I can go ahead and get rid of them. I see a lot of beginners like, it's not working. It's not working. Well, it's still running. You need to hit that stop button. If that stop button is active, that means that the program is still running. Even if it's not printing anything out, it's still running in the background somehow. You need to stop the program if you want to terminate it. Okay? So what's the solution here? What should I have done instead? I should have added my increment at the end of the loop. That'll print out 0 through 9. What will this print out instead? What's the first thing that it'll print out? 1. Why? Because you increment it, you initialize it to 0, but the very first thing that you do inside this loop is you go up to 1. So it'll print 1, 2, 3, 4. What's the last thing it prints? 10. Why? It was 9, which was less than 10. Increments, prints 10, and then it becomes 11, and then now it's 10, and so then it breaks out of the while loop. Right? So be careful. Let me go ahead and restore it to be more idiomatic. Usually you do the update at the end of the while loop here. But also, the last thing I'm going to show you that's going to dovetail into next week is you have enhanced for loops. Right? So let me go ahead and go over to my IDE here, and let's get rid of, yeah, okay. Well, I'm going to, we're going to get into arrays next, but let me go ahead and just jump into arrays here really quickly. Int primes is equal to 2, 3, 5, 7, 8, 9, 10, 11, 13, 17, 19. All right, that's good enough. Right? I've got an array of primes here. How would you normally print this out? For int I is equal to 0, I is less than. Now here's something that you don't know yet maybe, but I plus plus. All right. Let me go ahead and simplify this actually for now. 0, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of them here. So there are 8 primes that I've created. System.out.println primes sub I. This will work perfectly fine. It'll print 2, 3, whatever, all the way up to 19. Right? Here's an enhanced for loop, though. Rather than creating an index variable and iterating over it, int x in the collection primes. Right? It's a little bit cleaner, but it's an enhanced for loop, and it'll do the exact same thing as before. It'll print out everything in that array. That 1 is not part of the array. Is it? Oh, there. I needed to scroll over. Sorry. There's 2, 3, 5, 7, 11, all the way down to 19. That's an enhanced for loop. What that's actually called is a for each loop. Some languages provide a loop that for each element in this array or for each element in this collection and iterates over that collection. This is basically the same thing, except that it doesn't use the keyword for each. It uses for, and then the type, the local variable name, a colon, and then the collection. So for the way that you read that is for each integer x in the collection or in the